These are some practice problems from section 8.2, found on page 225. Let's start with number 9. Number 9 says draw hydroxide, OH minus. This is a polyatomic ion. I put the charge on the outside to emphasize the charge goes with the whole thing. The book puts it on the inside. And I think that can be confusing. Anytime we're drawing these guys, what we want to do is figure out how many electrons we need. So I'm going to list them out. I know oxygen is in group 6, so it has 6 electrons. I know hydrogen is in group 1, so it has 1 electron. I know collectively my ion, polyatomic ion, has a negative charge. How do I get a negative charge? I gain an electron. Remember, electrons are negative, so if I become negative, I must have gained an extra one. So I have 1 extra electron. Well, if I take my 6 and my 1 and my extra, I get 8 total electrons. Well, now I have to figure out the arrangement. Well, with OH, it's not too complicated. I really only have one possibility, to put them next to each other. So I have 8 electrons to give. Well, I know oxygen, who has 6, he wants 8. Because generally speaking, most atoms want 8. So I'm going to distribute the electrons around him and give him his 8 electrons. So I've given out all the electrons I have to give. Oxygen has an octet. That's his cloud right there. And hydrogen, his cloud goes right here. Now hydrogen is the exception to the octet rule. He only wants 2, so he's happy. So both of these guys are happy, and this is my end product. Number 10 on page 225 of the practice problems. So again, the first thing I want to do is list out and figure out how many electrons I have. So I have boron, which is in group 3, so he has 3 electrons. And I have 4 fluorines. Well, fluorine is in group 7. So if I'm in group 7, I have 7 valence electrons. Now my negative charge means I have an extra electron. I have gained an extra negative thing. So I want to account for that. Now I'm going to add these all up. So I have 28, 31, 32 total electrons. Now when I draw my structure, if I have an atom that's singular, a singular boron, I'm going to put him in the middle. Now I have 4 fluorines, and so I want to distribute them. I want to make a molecule symmetrical if I can. And so I want to make them all around the B. Try and make it the same on each side. Okay, so that's a legitimate structure. So now I have my 32 electrons to give out. And so I'm just going to start putting them around so that each atom can have 8. And I keep going until I give out 32 electrons. And that's 32. So I'm done if I have distributed all of my electrons and everybody has their octet. This fluorine has 8, this one has 8. Let me go ahead and circle them. Here's fluorine's cloud, he has 8. This guy has 8. That one has 8. And that one has 8. And my boron in the middle has 8 as well. So that's this molecule. Ionic, polyatomic ion actually.